Hello everyone, today in this video we will see 141 question in LeetCode, which is linked list cycle. Here in this question it is given that head, the head of a linked list, determine if the linked list has cycle in it. So we have to determine whether the linked list is having the cycle or not. So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that the tail's next pointer is connected to. Note that position is not passed as a parameter. So here we will see that 3, 2, 0, 4. These are the four elements that are present in the linked list. And if you observe that 4's next should not point to anything, right? That is what a single linked list. The last node won't be pointing to any other node. But since this node has a cycle, it is pointing to 2. So we can go from 2 to 0, 0 to 4, and 4 to 2. Again 2 to 0, 0 to 4, and 4 to 2. Right? So if let's see 1 to 2. Is there any cycle? No, because 1 to 2, and then from 2 there is no other connection here. Right? So here we will return false. In this case we have to return true. Now let's see how we can write the code. Before that writing the code we need to understand how it works. Right? See, if there is a cycle, okay, and two people are walking in the cycle, one person is taking one step at a time and one person is taking two steps at a time. So at some point, if they start from one point, at some point they will reach again, right? They will be in the same. First person is taking one step, the second person is taking two steps, then again one step, again two steps, again one step, then again two steps. Since this is a cycle, there is some point in which they both will met, right? They both will coincide. So this approach only we will use to solve this problem. So what we will do, we'll take two pointers. One pointer is slow and the second pointer is fast. Using these pointers, we will check. Slow pointer will move one step ahead and fast pointer will move two steps ahead. Now let's see how this works. So slow is pointed here. Similarly, fast is also pointed here. Now what happens? Slow moves one step ahead. Slow will be here. Fast moves two steps ahead. So fast will be here. Again, slow moves one step ahead. Fast moves again two steps ahead. So two steps in the sense from this 300 node will move to two steps, which is 300 next is 400, 400 next is 200. So we'll go here. Two steps in the sense here we are moving from 100 to one step is 200. So slow moved to 200 node. Fast is moving to two steps ahead, that is 200, which is one step, and from 200 next is 300, which is another step. So that is how we are moving. Again, slow moves one step ahead. Here slow will be there, and now fast moves two steps ahead. So fast will be 300, from 300 to 400, 400 to again here, right? So slow and fast are at same location. So we can say that cycle is present. If this is not the case, then we can say that cycle is not present. So how can we write the code? Simply, since fast is moving two steps ahead, that is from here to directly here, fast dot next should have some value, then only it can come here, and this next should also have some value, right? So this will be applicable in both slow and fast cases. So simply what we will do, we'll check while fast not equal to null, because there should be something at present, right? Fast. Okay, now we will write the code. See, while fast not equal to null and fast dot next not equal to null. Okay, in this both cases, we need to stop, or otherwise we can just run the code. Why? Because when fast becomes null or fast dot next becomes null, we cannot traverse further we cannot traverse further and we will get null pointer exception, right? And slow is moving one step ahead, so slow equal to slow dot next, and fast is moving two steps ahead, so fast equal to fast dot next. And what is the condition? If slow becomes fast, then we have to return true, saying that there is a cycle present. Or otherwise, after this loop is completed and we come out of this loop, we can simply return false. Okay, now let's traverse this. So slow and fast will point to the head node. Then, so slow and fast is pointing here. So fast dot next is not null, fast is also not null. So what we will do, we'll move slow to slow dot next. Slow dot next is 200, so we'll move slow here, and fast will move to fast dot next, which is 200. 200 next is 300. So fast will move here. Again, slow will move next towards. Wait, before that we have to check the condition. Fast not equal to null. Yes, not equal to null. Fast dot next not equal to null. Obviously it has 400, so not null. Then again, slow will move to slow dot next, which is 300, and fast will move to fast dot next dot next. Fast dot next is 400. 200's next is 200. So fast will move here. Again, we will check fast not equal to null and fast dot next not equal to null. Yes, they are not equal to null. Then what we will do? Again, we will shift to slow. Slow dot next is 400, so slow will point here, and fast. Fast dot next is 300. 300's next is 400. So fast will point to fast dot next, which is 400. Now both are at same location. That is the reason why we will return true, because there is a cycle. If in any case fast becomes null or fast dot next becomes null, then we can say that we have no cycle. Why? Because if we reach to the end, we are having a stopping point there. Now let's move on to the coding part. So here it is given as value, and instead of data, normally we will use data just in case we are using. So here it has a boolean cycle function, and here it is list node. Okay, so first I have to initialize head to slow and fast variables. List node slow equal to head, and list node fast equal to head. Then after that, same, while fast not equal to null and fast dot next not equal to null. Slow equal to slow dot next, fast equal to fast dot next. If slow equal to false, if slow equal to fast, then we will simply return true, else we will return, not else, we can simply directly write it outside of this while condition, return false. We'll run and we'll check it. Okay, so this has all the test cases covered. Thank you for watching. The code will be available in the description.